Okay. We're sorry we started class without you all, or I did. So we have reviewed the limit tree that we've done so far, how to approach a number. Today we are all about what do you do if x approaches positive or negative infinity? How do you find your limit? Don't change that screen yet. It is also going to have two branches coming off of it. And there's going to be a difference, and it's the type of function that kind of controls what you do. If you have a rational function, does anybody remember what a rational function is? A fraction, thank you! Rational functions are fractions. So if you have a fraction situation, how you work it is slightly different than if you have a polynomial. They both work along the same lines, but there's a little bit of difference. Okay, can I switch screens yet? No, yes? Okay, so let's go work some problems with limits that go to infinity. Yes, you are correct in that. Buzz Lightyear does fit well with calculus. Okay. Okay, I am going to show you the why this is a problem, and then I will show you the shortcut for how to work this. But the first time I do it, I have to show you how to do it the long way so it makes sense, but then we will discover the shortcut. Okay, right now, if we tried our usual stab of, let's sub the number in. Infinity squared over 7 times infinity squared plus 3. Now, what might that be? Because is the 7 times infinity squared bigger than the original infinity squared? I mean, you're taking 7 times it, but still, infinity is this. It's not a number. It's not a large. It's just an infinitely large number, so we don't know what it is. So you can't say which one's bigger than another. So obviously, this doesn't work for us to have infinities in there. We can't tell what it's going to come out to be. Because sometimes your answer will be infinity, but sometimes your answer will be a numerical value. So we got to have a system. What we're going to try to do here is we're going to try to perform a little algebraic trick on our problem and see if we can eliminate some of our issues. Okay. What I want you to do is look at that problem and identify what is the highest power of x you see in that problem. X squared. You see x squared. Okay. What I'm going to do then is I'm going to times the top and the bottom of the fraction times 1 over x squared, since that's the highest power. Like I said, this is the long way the first time, so you see why this works. What happens when you take x squared times 1 over x squared? It crosses off and you get 1. Those are gone, you get 1, yes. Okay. On the bottom, you're distributing it times both. So with the 7x squared, it's just going to leave you 7 plus 3 over x squared. Now, try subbing infinity in. We have a lot less x's. I would have, actually I don't need a limit, I'm just subbing the number in. I would have 1 over 7 plus 3 times infinity squared. Okay. Now, you have 3 divided by infinity. What happens when you take a number and you divide it by a very large number? It gets very, very small. Just think about it. 1/10 is 0.1. If we do we'll divide by something by 100, we get 0.01. If I divide by 1,000, I get 0.0001. I said that. 0.001. So if I'm dividing by infinity, I'm going to get 0.0000000000000. It's pretty much zero. In fact, we say it goes to zero. It's going to get so small, and as infinity continues to get larger, you're going to get so small that yes, we actually take this term out of there and we say it goes to infinity. That's what's happening here. It goes to, it goes to zero. I said that wrong. It goes to zero, and so therefore, if that part goes to zero, what's left? An answer of 1/7. Now, I want you to see the shortcut. You don't have to go through each time and take it times this fraction. Look at the original problem. Where did the 1/7 come from in the original problem? The coefficients on which terms? The highest powered terms. The highest powered terms control what you get. All the other terms just will eventually go to zero. So all you have to look at when you're doing limits to infinity is the highest powered terms. It is. It makes it way simpler. So we're going to go back and add that to our limit tree, maybe. If you are doing highest powered term, or doing a fraction, you use the highest powered terms from the numerator and the denominator. Now, I'm going to do some examples here. Sometimes the highest power in the numerator is not the same as the highest power in the denominator, and that's okay. But all you ever need to do is just take the highest power terms because they are going to give you the answer. Can I switch? Okay. Otherwise, I'm going to have to give a commercial. So, let's see if you can work one of these babies by the shortcut. I want to go to negative infinity this time. Okay, do you think it makes a difference if I'm going to negative infinity versus positive infinity? This fraction part of here where we had 3 over x squared and made it go to 0, if I divided by negative infinity, isn't it still going to go towards 0? It's still going to get really teeny tiny. Yeah. So since they're all going to go to 0, no. Whether you're going to positive or negative infinity does not have any difference except in one special situation that I will get to shortly. But most of the time, doesn't matter. So all you need to do is look at this problem and go, okay, what's the highest power term I see in the numerator? 4x cubed. Okay. Highest power I see in the denominator? 5x to the 4th. Okay. Now, with those two, just reduce it. What does that simplify down to? That'll give me 4 over 5x. Then, because my x cubed is going to cancel, leave me 1. Now, sub the number in. What's going to happen when I have 4 divided by, if I put 5 times in negative infinity, it's going to be 4 divided by a great big huge monster number is going to go to 0. Yep. So we're going to get an answer of 0. Oh, there's a video newsroom. We could do media production. Okay. fraction. We're going to negative infinity. What do I do? Okay, so Isaac's keeping the 5y cubed over the 3y. Take the highest power terms. All right? Then what?
5y to the second over 3.
Yeah, because you would reduce, 1y will cancel, and yes, I have 5y squared over 3. And then lastly? Yeah, so this time I'm going to have 5 times negative infinity squared on top. Okay, what happens when I square negative infinity? I would get positive infinity. And 5/3 times positive infinity is going to be infinity anyhow, yeah. So, yes. That's an answer where you just get an infinite answer. Okay. Are we having fun so far? all the infinity concepts, yes. And that's where calculus and eventually the mathematical area of analysis take us, is in the study of the infinite. What happens if you let something go on forever? And yes, it can play with your mind a little. Okay, here comes our special case. And this is going to take you back to see what you remember from Algebra 2. Nope, this was an Algebra 2 thing. Okay, why does this one look different than the others? It has a square root in it. It's even roots you're going to have to be aware of. Okay, and this takes a little talking. You start out, you do the same thing. What's the highest power you see in the numerator and the denominator? Yeah. So you're doing, okay. But it's technically x squared in a square root. The bottom is just 6x. Okay. I need to figure out what's the square root of x squared.
Positive or negative? X to the 1/2 power?
Well, it would be, yeah, it is an x. But you remember a special little rule about even roots, and they had an even power on the inside of the root. I call the rule, I teach it as even, odd. Does that, remember? But the question is, when you have a situation where it's even, odd, and by even, odd, I mean we had an even index, we had an even power, and once we broke it down out of the radical, this is the first power, so it ended up being odd. So you had to have an even, and an odd. What did that make you have to put on the x?
Plus or minus.
You have to remember, the square root of a number is always supposed to come out to be what kind of a number? If I give you square root of 4, you guys tell me, 2. Why don't you tell me negative 2? Because negative 2 times itself makes 4. Powers way back in the deep dark past said we're always going to work square roots and give what's called the principal root or the positive root. We're always supposed to guarantee we're giving a positive answer. In this situation, where x was squared, the square was making it be positive. But now that we've taken it out, can you guarantee me that that x represents a positive number? Nope. So what did we have to put on it to guarantee it was going to be positive?
Absolute value.
Absolute value. When you had even, odd situation, you had to put an absolute value sign on the result to guarantee it was going to be positive. So it's okay. It can run over a little bit. Let me finish my problem. Okay, so technically then, I got to erase my 1 now. That should be an absolute value of x. Okay, well now can I cancel the x's? You can't, because they're in the absolute value. Okay, and then you remember the other day when I showed you the definition of absolute value was a piecewise function? We said that absolute value of x, it's just x if you know it's greater than 0, but we write it as negative x if it's less than 0. Okay, in this case, since this is going to negative infinity, x is representing, if we're going to negative infinity, x is representing a negative number. It's less than 0, so what am I supposed to put on it? A negative. So therefore, for you to be able to drop the absolute value and be able to work with this, you have to make that a negative x. And then, finally, you can cancel your x's and say your answer is negative 1/6. Okay. You only have to worry about that if it's an even root, it went even, odd, and you're going to negative infinity. Because if you're going to positive infinity, it's just going to be plain old ordinary x like usual. So it's a fairly specialized case, but of course I will make sure it happens for you.